Hello everyone, this is the sixth video of deep learning series. In the previous video of deep learning, we have explained about what is optimizer and also explained different types of optimizer. So now in this video, I am going to show you by taking a dataset how to implement neural network in Python. So here I am using a diabetes dataset. The dataset is originally from the National Institute of Diabetes and Digestive and Kidney Disease. So using this dataset here we build the model which will predict whether a patient diabetic or not. So let's start. In this video you will learn 5 things. How to load data in pandas data frame, how to define a neural network in keras, how to compile a keras model using the efficient neural backend, how to train a model, and how to evaluate a model on test dataset. So let's start to implement neural network in Python. So the first step is what I am doing. I am going to import packages pandas, numpy, trend test, split, matplotlib, sequential, dense and accuracy score. Here I am import sequential and dense from keras model. So what is keras? Keras is a basically framework in Python that is help you to implement neural network model. I will explain what is keras in my previous video. The link is available in description box. If you want to know about keras model, keras, you can watch this video. So now let's come to the topic. So now as I told you, we have a diabetes dataset. Here we read the diabetes dataset using pandas data frame. Here you can see the first 5 records of the dataset. Here you can see column name, pregnancy. This number indicate how many times somebody was pregnant, blood glucose level, blood pressure, skin thickness, insulin level, BMI, diabetes, pedigree functions and age. So based on this information or these features, we can predict patient is diabetic or not. So by training the model, 0 means non-diabetic and 1 means diabetic. So here we predict based on the diagnostic measurement where the patient is diabetic or not. So basically it is a classification problem. Here we print the information of dataset using info method. Here we can see the column name, null count and data types. Here you can see there are 768 entries. And here the non-null count is 768 in each column, so we can say that in this dataset there is no null value present. Here we check the null values using isNA method. We can see there are no null values in the dataset. So now here we split the dataset. Here I am storing the features data in X variable and target data store in Y variable. So I am splitting the dataset in training set and testing set. Here I am using test size equals to 0.2. It means test is 20% and training data will be 80%. Now this is the main part of this model, training the neural network model. So in this code, what I am doing in the first line, we initialize the sequential keras model. So in the next line, model.add, I add the one hidden layer to initialize the model. This is a dense layer. It means it is fully connected layer. This layer declare in gives dense layer that has 18 neurons. Input dimension is 8. Here is I pass the 8 dimension because we have a 8 feature column in the dataset. So that's why I am pass here 8 and put the ReLU as an activation function. Now move to second layer. Here we add model.add. Here we want to fully connected layer, so we use dense. Here we pass 8 neurons. Now here no need to add input dimension because it is need only in the first layer. Activation function is ReLU. Third layer is the output layer. In the output layer we need only one neuron. Since this is a classification problem, so the output it has in terms of probability or in the terms of value is 0 or 1. So that's why we take here only one neurons and apply the segment activation function. So because it is useful for the classification problem, so here we define our keras model. Now here we have to compile the model. While compile we define a loss function. Here we use binary cross entropy and optimizer is equal to Adam. So there are different optimizer in the neural network. Here we use Adam. We have explained what is a loss function and what is optimizer in my previous video. Link is given in the description box. Here we use matrix equals to accuracy. We also use other matrix as well. Now here I am training data fit into the model. Here we use validation speed equals to 0.2 and epoch equals to 100. This is a one epoch. X trend and Y trend is the input of the keras model. You can see in every epoch weight and bias will get adjusted and the model accuracy will be improved. You can see here the accuracy is started from 0.64. After that some places it increase and some places are decreased little bit. So reason for this weight adjustment is happening in the background. So which weight is best for this model that the keras model give you at the end. Now here I am plotting the training accuracy and validation accuracy of this model. Here you can see the training accuracy and validation accuracy is slightly increases and training loss and validation loss is decreases. Now we come here, the test accuracy of this model is this 0.70. The model started from accuracy is 64 point something. After weight adjustment at the last it gives the 70% accuracy. So what is the accuracy of this model is 70%. So guys, in this video we have seen how to implement the neural network in Python using keras. So that's it for today. Thank you.